Hello everybody. We're going to finish up chapter 9 today. That leaves us one chapter left. We are done this course. I want to start by taking up some of the homework from last night before I move into today's note. So very quickly here, question number 1 says if we compare oxidation and reduction oxidation numbers, what happens during an oxidation number? Well, we know that in oxidation it's LEO, right? Losing electrons. And then one is gaining electrons. So if I am losing electrons, that means I'm becoming more positive. Let's go the other way. If I'm gaining electrons, I'm gaining negative charge, means I'm becoming more negative, which means my oxidation number is going down. If I am losing electrons, that means I'm becoming more positive, and my oxidation number is going to go up. Okay, so there's the first question. Okay, the next one says look at the oxidation numbers. So for oxygen, I'm seeing 0 because it's an element. For silver nitrate, it's an ionic compound. So silver is a +1 ion. +1. Oxygen's always -2. So if I've got 3 -2s, that's -6, but I only have 1 plus, so the nitrogen is going to be +5. If I look at manganese dioxide, again, it's an ionic compound. This one's a bit tricky. Manganese can have more than one possible ionic charges, so it's a multivalent ion. So I've got to figure out what it's going to be. Now, notice that oxygen is always -2, so I should have had a 2 down here, but I don't have a 2 here, which tells me that this must have been a 4 if this was a 2, and I've reduced them to their lowest numbers. So manganese must be +4. That's the trickiest one, I think, of the bunch, where the oxygen is -2. If I move over to zinc sulfate, again, ionic compound, zinc is always a +2 ion. Oxygen is always -2. So I've got 4 -2s, that makes -8, but I only have 2 pluses, so I need 6 more pluses for sulfur. If I look at chlorate, now the ClO3-, that's a tricky one now. Notice that I have oxygen, which is -2. I have 3 -2s, that makes 6 minuses. Notice I'm going to have a minus left over. So if I've got 6 minuses and I need a minus left over, I guess I must need 5 pluses for chlorine. If I look at the CO3 ion, I see the oxygen down here. Nice and easy always, unless oxygen's on its own. It's always -2. So I've got 3 -2s, that makes -6, but the whole ion has a charge of 2-. So if I have 2 minuses left over, but I've got 6 minuses from oxygen, carbon must be 4. If I look at some of these last ones, KMnO4, it's an ionic compound. Potassium is a group 1 element, so it's always +1. Oxygen in a compound is always -2. Yikes, it's getting messy. Smaller. So the manganese. So if I've got 4 -2s for the oxygen, that makes -8, and I have 1 plus, so I need 7 more pluses for the manganese. If I look at magnesium sulfite, I see magnesium, which is always a +2 on the periodic table. Oxygen is always -2 in a compound. So I've got 3 -2s, that's -6, but I only have 2 pluses, so the sulfur must be the other 4 pluses. And then, this one's tricky. So I've got sodium thiosulfate. I've got 2 sodiums, but sodium is always +1. Oxygen is in a compound is always -2, so let's see what I've got here. I've got 3 oxygens, that makes -6. I have 2 pluses for the sodiums, but I need 4 more pluses. Oh, but there are 2 sulfurs, so I guess each sulfur has to be +2. Okay, so again, I'm hoping that you're getting the hang of using these oxidation numbers. They are tricky, but like I said, once you've gotten used to them, you can master them pretty quickly. This one's nice and easy. This one basically says, what are the oxidation numbers to prove that this is a redox reaction? Hydrogen is 0, it's an element. Oxygen is 0, it's an element. Remember, oxygen is always -2 unless it's just an element. And then down here, oxygen is -2. Come on. While hydrogen is +1. And notice that the charge is balanced. I've got 2 negatives and 2 pluses. So there's my redox reaction. If I keep going down here, it's saying, is the following redox? Use the oxidation numbers. Again, I'm seeing that the calcium is an element. Whoops. Calcium is an element. Oxygen is -2. Hydrogen's always +1. So I've got 2 minuses and 2 pluses. If I move over to the right here, I can see calcium hydroxide. So the calcium is going to be +2 because it's an ionic compound. Oxygen's always -2. And hydrogen's always +1. So I can see I have 2 oxygens, which is -4. I have 2 hydrogens, which are +2. So I've got 2 more pluses missing, and that's the calcium. So I can see that it is a redox reaction. If I keep moving down, again, I can see this one is saying identify which reaction is oxidized and which reaction is reduced. So I can see that the hydrogen is going from 0 to +1. The oxygen is not changing, but the iron, notice that it's an ionic compound, so the iron was +3 at the beginning, and it's 0 at the end. So how do I go from +3 to 0? I have to gain 3 electrons. And how does hydrogen go from 0 to +1? It's got to lose an electron, lose some negative charge to become positive. Okay, so those are our Leos and Gers there. And then lastly, it says the following reactions are involved in the formation of acid rain. It says which ones are redox? Well, I can see right off the bat this one's redox. I can tell because oxygen is 0 here and it's -2 over here. I don't have to do any more to know that that is redox. Right, how about the next one? The next one has oxygens in compounds which are -2, -2, -2, hydrogens, +1, +1. And what about the nitrogen? On the left here, I've got 2 oxygens. Oh, actually, I'm not done yet. Over here, I have an oxygen which is -2. Okay, so notice here that the nitrogen has to be +2. Balance out. In this one beside it here, I've got 3 -2's, which is -6, +1. I need 5 more pluses. Let's go back to the other side, and let's look at the NO2 here. I've got 4 negatives, so I must have to have 4 positives. So let's see what changed oxidation numbers. I have oxygen on both sides. Oxygen here is -2, -2, -2, and -2. It's not changing. Hydrogen was +1 and +1. It's not changing. I only have nitrogen left. Notice what happens to nitrogen. This is a bit of a strange one. Nitrogen actually goes, some of the nitrogen atoms go from +4 to +5. Some of the nitrogen atoms go from +4 to +2. So it looks like nitrogen is being both oxidized and reduced. You say that's impossible. How can you be gaining electrons and losing electrons at the same time? Well, there are 3 in this reaction nitrogen atoms. Looks like 2 of them went up and 1 of them went down. So how do I go from +4 to +5? Right? If I'm going to do that, I have to gain some positive or I have to lose some negative. If I say, how do I go from +4 to +2, my oxidation number, I'm losing some positive, which means I am gaining some negative. So there's my Leo and Gur. So it's a redox reaction also.